Our profound understanding of the cosmos did not emerge overnight. The unsettling encounter Voyager 1 had with an unknown force may broaden our perspective on space in ways we never imagined. Without the journeys of these probes, our comprehension of space and some of humanity's most remarkable achievements would be incomplete. Yet, after decades of traversing the void, one of these probes seems to be encountering challenges. Join us as we delve into the mysteries of the universe and recount the incredible journeys of two explorers, two of the most groundbreaking space probes ever launched, navigating the vast expanse of space. Here's a glimpse into their fascinating story. Over the past 45 years, thanks to the twin Voyagers 1 and 2, a wealth of secrets about the universe has been unveiled. For 45 years, they have continuously gathered groundbreaking data. When these missions were first launched, there was no internet, no smartphones, and no modern technology we rely on today. Can you imagine that? Since Voyager 1's launch by NASA in 1977, the spacecraft has spent decades traversing the cosmos and offering us rare glimpses of the solar system's wonders. Here's an interesting fact. The mission's longevity far exceeded the scientists' original expectations. Despite years of research on Earth, the conditions in space proved to be vastly different. The spacecraft traveled at incredible speeds relative to the planets, achieving critical milestones much faster than anticipated. This allowed the initial 30-year mission plan to evolve into an extended journey. Although the two spacecraft were launched just 2 weeks apart, following slightly different paths, Voyager 1 quickly took the lead. Remarkably, it reached its destination in just 12 years, less than half the originally estimated time. That's right, 12 years is considered rapid in terms of space exploration. Moreover, Voyager 1 became the first spacecraft to reach the boundary of the solar system. This route, however, carried significant risks, with a higher likelihood of something going wrong. The possibility of becoming lost in the infinite expanse of space was a very real threat. These two probes have profoundly advanced our understanding of space exploration and science. Scientists and NASA engineers remain astounded by the data and images captured by the twin Voyagers. They revealed the iconic Great Red Spot on Jupiter and captured humanity's first close-up images of the planet. These missions also delivered astonishing discoveries about numerous celestial bodies, such as the presence of water on Europa, the identification of the largest natural satellite in the solar system, and evidence of active volcanoes on Io. These findings unveiled phenomena we never knew existed or thought possible, enriching our knowledge of the solar system in extraordinary ways. Isn't that fascinating? Nearly 13 years after its launch, Voyager 1 reached Saturn, its initial primary destination. With more detailed information about the planet's wind speeds and its short 10-hour days, scientists gained deeper insights into its dynamics. A 10-hour day, can you imagine? It feels so brief compared to our 24-hour cycle. The spacecraft also provided critical data about Titan, Saturn's moon, including its nitrogen-rich atmosphere. Additionally, it discovered 10 previously unknown moons around the distant planet. After gathering this valuable data at Saturn, the two spacecraft diverged to pursue separate missions. Voyager 2 continued its journey toward the final 2 planets of the solar system, while Voyager 1 altered its course to explore the heliosphere. These 2 voyages raised several new questions, as well as contributed to the answers to many others about the vastness of space. For example, Voyager 2 collected hitherto unseen data on Neptune, a planet traditionally thought to be inferior by scientists. How a planet so far from the Sun, receiving so little solar energy, could sustain such varied weather patterns and climates astounded and perplexed them. By 2004, both probes were extremely far from home and had arrived at what might be termed the far limits of our solar system. They had arrived at the termination shock, a location in our solar system where the winds dropped from millions of miles per hour to a meager 250 miles per hour, a pace that was nothing in comparison to the blinding intergalactic speeds. Nothing in space and the solar system is little. Even though Voyager 1 had reached its limit, it still needed to pass through the heliosphere to enter interstellar space. Let us now explain what the heliosphere is, in case you were wondering. It is, in essence, a shield that protects our solar system and the planet from the intense radiation and energy of interstellar space. Nothing has traveled as far into space as Voyager 1, which has covered an incredible 12 billion miles since it was launched 45 years ago. Even though technology has advanced light years since then, the fact that this was accomplished with relatively little technology is even more amazing. Neither of the probes had a microprocessor on board. Those were non-existent even 10 years ago. The fact that there is very, very little software contributed to the prolonged survival of the situation. Scientists and engineers surmised that the necessity of hardwiring everything was the reason for its extended functionality. The probes could operate for such a long time because the onboard processors were, at best, extremely low-power devices. An 8-track tape recorder held all of the data that the instruments aboard the probes collected and recorded. It was returned to Earth using a device that consumed the same amount of energy as a refrigerator light bulb. Well, isn't that just crazy? The amount we accomplished with such archaic technology is astounding. Is it feasible for us to achieve all of that without sophisticated technologies and a touchscreen? A horrifying first meeting. However, there is an issue. Voyager 1 appears to be having issues after 45 years in operation. Has communication with aliens finally been established? Is space travel far riskier than we thought? Is there a much simpler explanation? How is our reliable space shuttle Voyager 1, situated roughly 14.5 billion miles from Earth, holding up after decades in space? Astonishingly, Voyager 1 remains operational. However, after 45 years of solitary travel through the vastness of space, a spacecraft inevitably starts to show wear and tear, and this is beginning to manifest. Even though Voyager 1 seems to be functioning normally, scientists have discovered that they can't determine its exact location. We are unsure of where it is, even though it hasn't entered safe mode or triggered any warning signals. NASA scientists and specialists are puzzled, but not entirely surprised. Such malfunctions in a probe of this age are not entirely unexpected. What exactly has happened to Voyager 1, and what has it encountered during its journey into uncharted interstellar space? Could there be a mysterious external influence, or is this merely a sign of aging technology? Scientists speculate that the probe might be experiencing electronic aphasia, a condition that disrupts communication and makes interpreting the transmitted data challenging. NASA suggests that the data Voyager 1 is sending might be random and unrelated to the actual status of its Attitude Articulation and Control System, AACS. Instead of providing routine updates about its health and conditions, the AACS, which is responsible for keeping the high-gain antenna pointed toward Earth, began transmitting corrupted data. To conserve energy and prolong the mission, which is set to conclude in 2030, NASA has spent the past 3 years turning off non-essential systems. Despite these efforts, there are still occasional setbacks. Interestingly, Voyager 1 continues to function strongly despite the confusing signals. It's reassuring that the probe's antenna remains locked onto Earth, as the radio signal is steady. This indicates that Voyager 1 is still properly oriented, even if its location data is inaccurate. Additionally, the fault protection system, designed to safeguard the spacecraft during malfunctions, has not been triggered by the current issue. When NASA investigated the anomaly, they discovered that the AACS had been sending telemetry data through an onboard computer that had malfunctioned years ago. By identifying and addressing the root cause, they hope to prevent similar issues in the future. The erratic signals are perplexing, but while the situation isn't currently critical, NASA scientists are working tirelessly to decode the latest enigmatic transmissions from the decades-old spacecraft. Voyager 1 was built to withstand the extreme and unpredictable conditions of space. During its journey within the Sun's magnetic field, the probe has been shielded from high-energy particles and solar radiation. While high-energy particles can occasionally strike its computer chips, causing minimal damage, the effects can accumulate over time. Fortunately, NASA engineers anticipated such challenges and designed Voyager 1's systems to endure them. The termination of a period, everything worthwhile has to end. Even with the mission's success, difficult choices must be taken to allow for future growth. The Voyagers appear to have crossed the finish line. We could be coming to an end after 45 long years in deep space. The most recent bug and malfunction in Voyager 1's onboard computers and AACS will force it to retire. The American Space Agency has started shutting down its systems and bidding the probe goodnight. Amazingly, humanity was able to send probes into space that lasted for such a long time, even before the development of current technologies. After 2 identical probes gave humans the closest views yet of the 2 largest planets in our solar system, the mission has come to an end. The probes will be decommissioned by 2030. NASA is extremely satisfied with both Voyagers' performance, noting that they have operated 10 times beyond their guarantee. There are 4 operational components left in the first Voyager probe and 5 in the second. They are being powered by decaying plutonium, which will eventually run out. The battery output decreases by 4 watts annually, forcing NASA to make some difficult decisions. NASA scientists have been gradually turning down components of the probe. In 2019, for example, they turned off the heater for the crucial cosmic ray detector. The magnetometer and the plasma science instrument will probably be the last to be removed. When NASA dismantles the spacecraft piece by piece, the surplus heat produced by the onboard processors keeps these enclosed within the spacecraft's body. The others will take the longest to cool, as they are hanging on a 13-meter fiberglass boom. A further justification for ending the mission is the distance the Voyagers have traveled from Earth. At the moment, sending a radio transmission to Earth takes 22 hours for Voyager 1 and 18 hours for Voyager 2. That period grows by 3 to 4 light seconds every day, making communication more difficult as the probes get farther apart. The whispers from the spaceship are harder to hear because of Earth's noise and the scattered signals. The faint information received appears to be unreliable due to a recent glitch in its systems. History and future potential. The significance of the 2 Voyager missions cannot be overstated. They have provided extraordinary and invaluable insights into the vast, largely unexplored reaches of outer space. It may take another 300 years before humanity can journey to the very edge of our solar system. But astronomers might achieve access to interstellar space shortly. To enable the operation of modern spacecraft, Voyagers 1 and 2 paved the way. These spacecraft have essentially become historical relics. It is challenging to grasp their monumental accomplishments today, especially considering their memory systems hold 3 million times less storage than most contemporary smartphones. Although they operate at speeds nearly 40,000 times slower than a 5G internet connection, they remain effective. Both Voyagers carry a golden record, a message from Earth to the cosmos, translated into 55 languages and featuring images of iconic individuals and locations on Earth, as well as music. Humanity's fascination with communicating with extraterrestrial life seems eternal. Jamie Rankin, an astronomer and member of the Voyager mission team, reflected on the mission's legacy and future. He expressed satisfaction with its remarkable and unforeseen success, achieved through the collaborative efforts of multi-generational teams. Despite being based on outdated technology, never intended to endure this long in space, the Voyagers have exceeded expectations. The contributions of these missions should not be underestimated. Though they may have receded from public attention in recent years, the 2 probes, with their antiquated memory and transmission systems, remain indispensable tools for advancing our understanding of the cosmos and continue to stand at the forefront of space exploration. The Voyager missions represent a triumph of human ingenuity and determination. When NASA launched Voyager 1 and Voyager 2 in 1977, no one could have anticipated the profound impact they would have on our understanding of the universe. Initially designed to conduct close-up studies of Jupiter and Saturn, the Voyagers surpassed expectations, providing humanity with the first detailed images of the outer planets and their moons. Voyager 2's flybys of Uranus and Neptune added even more groundbreaking discoveries, solidifying the mission's reputation as one of the most successful space exploration programs in history. Voyager 1's entry into interstellar space in 2012 marked a historic milestone, as it became the first human-made object to leave the heliosphere, the protective bubble created by the sun's solar wind. This achievement provided scientists with unprecedented data about the boundary between our solar system and interstellar space, offering insights into the nature of cosmic rays, magnetic fields, and the interstellar medium. Voyager 2 followed suit in 2018, further enriching our understanding of these uncharted territories. One of the most remarkable aspects of the Voyager missions is their longevity. Operating far beyond their original design lifetimes, the probes have continued to send back data from billions of miles away, despite the challenges posed by their aging hardware and the vast distances involved. This resilience is a testament to the meticulous planning and engineering that went into their construction, as well as the dedication of the teams that have maintained them over the decades. As the Voyagers approach the end of their operational lives, their legacy is secure. They have inspired generations of scientists, engineers, and space enthusiasts, serving as a reminder of what humanity can achieve when we dare to explore the unknown. Their golden records, carrying messages of goodwill and the sounds of Earth, will continue to journey through the cosmos, a symbolic gesture of humanity's desire to connect with other intelligent beings in the universe. Looking ahead, the lessons learned from the Voyager missions will inform the development of future interstellar probes. Projects like the Breakthrough Starshot Initiative, which aims to send tiny spacecraft to the nearest star system, Proxima Centauri, owe a debt of gratitude to the Voyagers for paving the way. Advances in propulsion technology, miniaturization, and communication systems will enable humanity to explore even further, building on the foundation laid by these pioneering spacecraft. In addition to their scientific contributions, the Voyagers have also had a profound cultural impact. Carl Sagan's famous reflection on the pale blue dot, inspired by an image taken by Voyager 1 from a distance of 3.7 billion miles, has become a powerful reminder of our shared responsibility to care for our planet. The image, which shows Earth as a speck suspended in a vast cosmic void, underscores the fragility and interconnectedness of life in our lonely little world. The end of the Voyager missions marks the conclusion of a remarkable chapter in the history of space exploration, but it also heralds the beginning of a new era. As we bid farewell to these intrepid explorers, we can look forward to the next generation of spacecraft that will build on their legacy, pushing the boundaries of what is possible and deepening our understanding of the universe. The Voyagers may be fading into the silence of interstellar space, but their impact will resonate for generations to come.